Hey, so forgive the mess, but I'm in the middle of cleaning tanks and building one and whatnot, but I have to do a pH treatment on one of my systems here, and something that's always bothered me that I'm curious if somebody can help me figure out, right? So if you look at the back of these bottles, I do everything by weight because my tank sizes, but so this one right here is the acid, and the acid specifically states that for every 20 US gallons, you use 2 grams. And so this, and then with the alkalinity, and you have to use these in conjunctions with each other. So if I'm trying to hit 7.0 pH, I need to put in twice the amount of alkalinity that I do the acid. It's a 1-to-2 ratio, right? However, for this, for every 20 US gallons, you put in 7 grams. So far so good, right? But the math doesn't add up. So if you start from the alkalinity bottle first, my system right here that I'm working on is 90 gallons. So 7 grams per 20 gallons. So 90 divided by 20 gallons is 4.5 units, right? So figure 1. So 7 grams times 4.5, which is the amount of units that I need in order to treat the 90 gallon tank, equals 31.5 grams of alkalinity. And like we said before, the ratio is 2-to-1 for the alkalinity. So for every 2 parts of alkalinity, I need 1 part acid. So if I divide it in half, it equals 15.75 grams. So from this direction of calculating it, you get 31.5 grams of alkalinity and 15.75 grams of acid. But if you do it backwards, right? So it's 2 grams per 20 gallons of acid, and so that same number from before, because it's a 90 gallon tank divided by 20, because it's 20 per unit. So 2 grams, which is what this one is, times 4.5 equals 9. And this is the one that's half of it. So I didn't do the rest of that math there because I kind of stopped for a second. But if you times 9 grams times 2, it equals 18 grams. So I don't know if you guys noticed this, but if you calculate it from the alkalinity bottle, you get 31.5 grams of alkalinity and 15.75 of acid. But if you do it the other way around, you get 9 grams of acid and 18 grams of alkalinity. Why is that? I mean, because it doesn't state specifically which bottle to start from. I just... The only thing I can think of is, because obviously these have counterproductive parts, but basically the reason you use them in conjunction is the buffer will just get completely eaten away if the other one isn't there to kind of, buffer it up, so that the alkalinity will basically instantly disappear. So this kind of stabilizes it, basically. So the only thing I can think of is if you're going from the acid direction first, this is technically a pH lower, and this is a pH raise. So my guess is if you're trying to lower it, no, that doesn't even, my hypothesis doesn't even make sense though, because if I'm trying to lower it, then I just change my formula. It doesn't even matter which one you start with. So, I don't know. Does anybody understand why you get different numbers? Because intuitively, you would obviously want to use the one where you have less, consumption. Why would I want to use more material if I get the same results? But my heart tells me that the larger one is probably the correct one because I want to raise pH, and the one that raises pH is the alkalinity, and that's the formula. If working off its back, that's the number that I get. So I don't know. I've always done it that way. I've never had any issues with the larger numbers. I've actually, I think, once did it with the lower number. I don't think I had any issues per se. I don't know if I hit my targets. I need to do this a little more closely. But anyways, I'm just curious if anybody can help me explain this. Anyways, thanks.